Hi guys, it's your guy Olumide, and today we are gonna be solving another one of the most commonly asked tech interview question, the longest substring with unique characters. So it's commonly asked by top tech companies including Google, Amazon, Netflix, Meta, Apple, Microsoft, and other top tech companies. The problem statement states that given a string, determine the length of its longest substring that consists only of unique characters. So we are going to be given a string just like in this example, the string S, that is a string of ABCBA, and we are asked to return and determine and return the length of its longest substring that consists only of unique character. So and the output here is 3. Why? Because the length of the longest substring, don't forget S could have a lot of substring. It could be A, it could be AB, it could be ABC, it could be ABA, it could be BCB, it could be CBA. Any combination of substring or of sequence in the string S could be a substring. So but now the condition is that I want to find the length of the longest substring that won't contain duplicate characters. Look at this instance where we have ABCB. We see that B is occurring twice, so we are not going to return the length of this subsequence even though it is a subsequence of X. So but rather consider ABC. We are going to be returning ABC is still a valid subsequence containing unique character because it only contains A, B, and C, and that's why the output is 3, because so far ABC and CBA are just the two substring of X that contain unique character, and the length of both is 3. So that's what we can see in this example and in this explanation here, that the substring ABC is the longest substring of length 3 that contains unique character. Similarly, CBA is also a substring that fits this description, this condition, because it also contains unique characters and is a substring of X. A brute force to solve this problem is to consider every possible substring of the string X. So considering every possible substring of this string, then we are gonna check for each substring that has unique character. Out of every possible substring, we are gonna look for, we are interested in the one that satisfies the condition of having unique characters. So once we get the ones that have unique character, then we can find out and pick the substring with the longest length, because the problem statement asks us to determine the length of the longest substring. So we can have multiple substring containing unique characters. Like now, A actually is a substring of S that contains unique character. AB also contains unique character. ABC contains unique character and is a substring of S. But we see that ABC actually have more lengths. ABC has the highest length out of AB and A. So after selecting every possible substring, we then go for the ones that have unique characters, and we are interested in the one with the longest length out of all possible substring of S with unique characters. In doing this and in solving this problem, we need to find every possible substring of S, and that's gonna cost us 2 nested loops. So why? Because for each substring starting from A, we want to examine the rest of the strings or the rest of the substrings, which is B, so we can compare A to B as a substring AB. So and similarly, you can do ABC and doing ABCB, ABCBA. So that way, after doing that, we still go back to B to consider the rest of the substring that is possible with B. So and that's gonna cost us 2 nested loop. First one to iterate through A, and the second one to iterate through A plus or the position A, which is the first position, plus 1, so it can iterate through the rest of the array and compare with A. So and in the process of doing that, we are going to be creating an hash set that is going to store every unique characters so in the string. So like now, when we are looking into A, we are going to put A into the hash set, so that if we come across A again, whenever we are trying to find out the possible substring, we will know that A is a duplicate, so we are not going to consider that substring. So in solving this problem, it's going to cost us, like I said, a two nested loop and another additional loop. So because first of all, the two nested loop is going to help us generate every possible substring, and the nested loop, the third nested loop, is actually going to check if a particular substring or a particular character is already in the hash set. So first of all, we are getting every single substring or every possible substring of S, and for each of these substring we are looking if they satisfy the condition that that particular substring contains unique characters, and that's O3 or let me say O n raised to power 3 time. So it's a quadratic time, and that's quite inefficient. So we need a more efficient solution in solving this problem, and that's where the sliding window technique comes in. Since the problem statement asks us to look for the longest substring that satisfies a specific condition, in this case the substring should contain only unique characters. So we see that dynamic sliding window technique will go best for this, just like we discussed previously in our previous video on sliding window. We have two sliding window technique, the fixed and the dynamic, but now we are not actually asked to find 3 or 4, we are just asked to find the longest. So and we are going to be using dynamic, not fixed but dynamic sliding window technique to solve this problem. To solve this problem, we can consider and categorize every window or any window into two categories. So first of all is a window without duplicate characters. So don't forget, we are going to be using sliding window technique, and it involves placing a left and a right pointer to form the boundaries of the window, and in between this left and right pointer are going to be elements, let me say element of the array or iterable objects that we are working on, like a string or sequence. So now is either the window contain no duplicate character, or it contain duplicate character, that is at least one character that have a frequency that's greater than 1. Just like in this case now, we see that it contains duplicate character. The window, the left pointer or the left boundary of the window is at A, the right boundary is at B, but in between there's also a B. So there's a duplicate, but right here no duplicate because we have A, B, C. The three elements or contents in this window are unique, unlike this one here that contains duplicates. So these are the two scenarios that we can have when solving this problem. Now if A is true, if the window contain no duplicate character, that is the current window based on the left and the right pointer, the position of the left and the right pointer, if this window does not contain duplicate character so far, just like in this case, what we do is that we expand the window by shifting the right pointer to the left and to the right by 1, so that we could have a larger window or a more lengthier window of unique characters. But in a situation whereby the window contain duplicate character, what we do is that we shrink the window by shifting the left pointer toward the right until it satisfies the condition that we have. Look at in this case now, whereby there's a B here, and right now since we have come across a B and a B is already existing in the window, previously, this B particularly here, what we do is that we shift continue to shrink the left pointer until the B doesn't exist there again, until the window satisfies the condition of unique character. And because of that, we're going to be shifting the window the left pointer of the window from A to B. When we shift the left pointer from A to B, still B is still duplicating the window because the window is now BCB. So again shift the left pointer from B to C, and at that point now it satisfies the condition. We can now continue to expand by shifting the right forward to look at a more lengthier window. Let's try the logic over this particular example here, this example string that contains ABCBA, just like the one that's given to us in the problem statement. And right here we have an hash set that's going to help us to track the characters that already existed in the window. So to use this sliding window technique, we are going to be initializing the left and the right pointer that represent the boundaries of the window, and also we are going to be using an hash set to keep track of unique characters or the characters in the window. Now let's start looking for the longest window that satisfies this the condition of unique characters. So at first, the right and the left pointer are going to be at the first element or first position of the string in the 0, and we are going to expand the window so to look for to make the window more broader and to look for more unique characters. So expanding, we are going to shift the right pointer by 1 to the right, just like here. So, and in the process of shifting, we have our A added there. So really, the current state of the hash set is the state before shifting the right pointer. So right now it is empty, and now that right pointer is shifted one step to the right, we added A. So but right, we know really that A and B will be added, and that's why it's added right here. So it's just representing for a more better visualization and representation. I want to put it forward as the previous state, so but you understand as we go on. So right at this point, we try to check if the element that the right pointer is pointing at, if it is in the hash set, but hash set is empty, always empty by default. So that's why I try to put the visualization this way. So what we do is that we are gonna expand the window, and don't forget, expanding means shifting the right pointer by 1 to the right, and we are gonna keep track of the visited or encountered element or characters in the hash set. So therefore we're gonna be adding A to the hash set, and that we did there, we had A to the hash set right here. So right pointer has shifted to the right by 1 to look for a more broader window that satisfies the condition, and B also is not in the hash set because hash set only contain A, which is the first element. So what we do now, B is not in the hash set, so we're gonna expand the window again. So and what does it mean? It means adding B to the hash set now, so that we can be sure that we have seen B and that it is included in our window, and we're also gonna be shifting our right pointer by 1 to the right. So and that's what we did right here. We shifted our right pointer to the 1 and we added B to the hash set. So right pointer is now currently laying on C, on the third element in the iterable in the string. So and we're gonna check again if C is in the hash set. C is not there, so what we do is that we shift our right pointer again to the right to look for a broader window that satisfies the condition, because the problem statement asks us to find the length, or let me say the longest length of a substring that satisfies the condition. So even though AB satisfied the condition, A alone also satisfied the condition, but we keep shifting, we have to keep shifting the window to look for a more larger length as much as possible. So we're gonna add C also to the hash set, and we're gonna shift our right pointer to the right. And right here we have it added, and now we are shifting our right pointer by 1 and it's now at B, but B is in the hash set. So what do? We shrink the window until it satisfies the condition again, and it will satisfy the condition when B is no longer 2 in the hash set. You understand? When B is just 1 in the hash set. So what we're gonna do is that we're gonna shift, and what we can do that is by shrinking, by shifting the left pointer to the right by 1. So when we do that, we shift it, and because we shift it, we have to update it in our hash set. We have to remove it from the hash set. So we remove A because it is now we try to shrink it. Why we have to do that is because in the process of shrinking, you understand, the length is initially 4. Let's say the length is 4 A B C B, but now that we are shrinking, it becomes B C B. So we have to update it in the hash set now to be B C B, to be we have to remove A from the hash set, so it's not going to be counted. So what we're gonna do now, you just follow along, is that again, because B is still in the hash set, what we do is that we shift the left pointer again by 1 to the right. So by this time, when we shift it this time, we have CB because left pointer have shift from B again to C, and now you see that we remove B from the hash set. It has to be updated. So at this point, only C is in the hash set, so B is not in the hash set. And what we're gonna do is that now we are gonna add that B. So don't forget, hash sets won't contain duplicates. You understand? So what we try to do is we delete adding the duplicates until we make sure that we have removed the previous one. Why? Because if we added the duplicate anyways, is only one will be in the hash set. You understand? Hash set won't contain duplicates, and so we really need to remove the duplicate that was once there before adding this new one. So after making sure that B is no longer in the hash set, we can now add B, which is the B that the right pointer right here is pointing at. We're gonna add it to the hash set, so we have CB, and now we can shift our right pointer to 1 to continue to look for a more broader window. So and shifting from B to A now, we see that A is not in the hash set. A is not, sorry, you understand? That is why we have to update our hash set. You know, RDB will not update it now. We will think A is still there. So whereas left pointer have shifted away from A, so A is actually not in our hash set. So we are gonna add this A that the right pointer is currently pointing at. We are gonna add it to our hash set, and we expand the window. But we realize that at this point, if we expand the window, it's gonna, it has gotten to right pointer has gotten to the end of the loop, end of the string. So we're just gonna cut out and return the maximum length that has been found so far. And if we see, the maximum length is 30 ABC. So as in the maximum length, we'll be keeping track of it using a variable, the maximum length that satisfies the condition. So in this case too, we're also gonna be having A added right here. So here is gonna be added right here because at this point A is no longer in the hash set, so it's gonna add it. So, and that means we have two string, ABC and CBA actually owns the longest substring in S that has unique character, and we see that both of them have the same length of 30. So we're gonna return 3, and that's how we're gonna solve this problem. That's the logic behind this problem. Just define two variables, the left and the right pointer, and then you try to keep expanding the window as far as it still contains unique characters, and that's gonna depend on the hash set. Hash set is gonna help us track if it contains unique character or if there's going to be a duplicate. So in a situation whereby there's going to be a duplicate, you just keep shrinking the window by shifting the left pointer further to the right until the duplicate is removed, until it satisfies the condition of unique characters. Then you can keep on you can add the right pointer at that point whereby duplicates want to occur, and you now can keep on expanding the expanding the window by shifting it further to the right until you get to the last element in the string. And along the way, you'll be keeping track of the length so far. And now you can keep track of the length is by doing right minus left plus 1. You understand? So look at this situation now. The left pointer is at index 2, right? And the right pointer is at index 4. 4 minus 2 gives us 2. 2 plus 1 make up 3. So you see that 3 is the length of the window. So at any point in time, after shifting your left to ensure that no duplicate is contained, and after shifting your right to reach out to the highest, you can always do right minus left plus 1 to know the current length of the window. And so depending on the previous length that we have met, don't forget that we first met the first length A, we have AB, then we have ABC. So ABC held the longest length previously, just before we have CBA. So depending on the previous, we are going to be using a maximum length to keep track of the whole maximum. So it's going to decide whether the maximum length is still going to remain the maximum, or this particular right minus left plus 1 is going to be the new maximum. That is if this right minus left plus 1 is greater than the existing maximum. Why? Because we just need the longest. So we're going to be going to the code implementation now.